Now I'd like to start with configurable applications. Let us look at main for the latest application graphic, which involved multiple class instances. This is just so simple, it doesn't need to be done in source code really. It could be loaded from a configuration or be defined at runtime. But what is the advantage of not doing it in source code? The advantage is that we make applications inherently flexible. When stepping from C to C++, the decision maker of what exists had been changed from linker to constructor calls. Now the decision maker changes from source code constructor calls to runtime configuration. A decision at compile time has been replaced by a decision at runtime. I believe that this thought will have to be digested before you can realize the consequences this may have. Let us look at what such a configurable application may be made of. So here's the next slide. First of all, we want blocks with input nodes and some output nodes. Some blocks have output only, for example AD converters, and others have input only. These are typical for representations of hardware peripherals because they produce data or consume data. They are the interface between our system and the outside world. What does a building block consist of? Here is a larger building block with enough space for further detail. Obviously, the building block is implemented by a class. The inputs of the building block are subscriber functions, which are class members. And the outputs of the class are data objects. Of course, you can have any number of inputs and outputs as needed. Pairs of inputs and outputs that refer to the same data are very useful for parameters of a building block. For example, for a PID controller, one needs to be able to adjust the factors of the P, I and D parts, for example. These are inputs as well as outputs. There is another interesting aspect about building blocks. Each building blocks lives in its own library. Why? Well, again, this adds to the flexibility of the system. The aim is to come up with a system where you can simply pick the building blocks and insert them into a running system. When you create a new building block class and want to make it known to the framework, it's much easier to add a library than having to add new source code. As a side effect, the separation into libraries enforces independence between building blocks too. If the target supports dynamic linkage, then this addition of new building blocks can even be done at runtime by simply copying a ready compiled library onto the target. Let us go back again and think about how a framework could combine building blocks into a real application. Here is how an application would have been programmed from main. A few classes were created and then the data links between the classes had been established. This gets boring and tedious for a programmer. But hey, we're programmers, not typists. Can't this be done better? Yes, it can. These lines amount to a programmed configuration. To keep this configurable at runtime, we need a list of existing modules or building blocks available in the system, then another list of the desired instances of building blocks, and finally a list of data links between the instances. Each of these states something like take the output from instance myADC, output node outval, and link it to the input node inval of instance PID control, and run this link at highest priority 0. The first list of existing modules is relatively fixed. The two lists of runtime instances and the list of data links effectively define the whole application. Actually, the list of runtime instances refers to the existing modules list. This is similar to two database tables with referential integrity. The same information contained in the two tables, runtime instances and data links, can also be visualized graphically. The yellow blocks are the instances that can also be found in the list. The data links table is not shown. The graphical representation is human-friendly, while the list is machine-friendly, and because it's text, it's more comparable. Now I'm going to add a clock to this running system. The framework includes a command line interpreter. If I type inst tick tick, the instance lowercase tick of building block uppercase tick gets added to the system. We see this as a new yellow block as well as an added entry to the table. The output of this instance is a second counter. To get minutes, I need a divider for which I use a generic scalar building block, and I name it sec to min to hint at its purpose, namely convert seconds to minutes. The command line for this is instead sec to min scalar. To get hours, I do the same again and name it min to hour. Now I set the divider parameter to 60 for the sec to min scalar using the command inst node set sec to min divider 60. And the same again for the other scalar. Now I add a data link using the command data link add tick count sec to min in value 1. This means send the count output of the tick instance to the inval input of the sec to min instance using a medium priority. I do the same again to send the total minutes to the min to hour scalar. That's it. Hours are in min to hour .outval, minutes are in min to hour .rem for remainder, and seconds are in sec to min .rem. Okay, a clock without a graphical user interface is pointless really, so now I'm going to add that to the running system too. The yellow boxes are the enlarged picture from the previous slide. At the bottom you can see a hinted at ring of dialogues. With the command create dialog clock dialog, I insert a new initially empty dialog and give it the name clock dialog. Then I create a label control, and with the second command, which is not shown here, I place it on the clock dialog. Now I create another dynamic label control that displays the total number of seconds. This control is linked to an out node of an instance, namely tick count. Behind the scenes, the control's subscriber function gets registered as a low priority subscriber for the diode whenever this dialog is active. Thus no special code is required for linking the control to data. I add another dynamic label for the seconds, and another one for the minutes, and one for the total number of hours. That's it. Okay, I've been trying to provide you with a quick round trip through various steps and combinations of techniques. But what is its use for real-world software projects? Once the building block libraries have been loaded onto the target, I can start modeling the application. The response is immediate. At the moment I type the command line instead, the instance will immediately be created on the target. When I type data link add, the new instance starts to participate in the application's data flow. And when I type create control, a graphical control on a user interface appears that represents the underlying data. This makes it possible to create an application by trial and error. The round trip from coding, compiling, loading, starting and checking is much longer. And because I've probably spent half an hour coding on the last minute change, I'm not likely to throw it away too easily if I coded it. Now it's just the latest click I don't like, and so I do not hesitate to undo this. I want to make one point very clear. So far, application development meant writing or generating source code. With this approach that I propose, it is now possible to separate A. the coding of the building blocks and B. the live configuration or modeling of an application. What impact can this have on the application development process? Firstly, I separate programming of building blocks from configuring of applications. Building blocks are isolated and can be stress tested easily. Reuse of building blocks across application is very easy too. Application configuration can be tried out. Programming of building blocks and application configuration can be done by separate groups of people. I can also respond to customers' special wishes easily without risking the stability of an existing product. This can be accomplished by any skilled person who does not need to be able to program. One last point. Because of this flexibility, I may increase my share on the market, but I may have to cope with an increased number of product variants because it's now so easy to create a new, slightly modified product. On this slide, I've just summed up the features of the parts I discussed in this presentation. You can read these for yourself. Thank you very much for your attention. Here on this last page, you see an overview of how the parts of the building block framework work together. Just send me a quick mail if you want to be kept up to date on this, or if you have any questions. Then I'll send you a link to a demo project for download as soon as it's ready. And here is a very short video of how I actually came up with this system and how it's running on a real target, which is after I finished all the drawing. So thanks again and have a nice day. Bye bye.